Hello, everyone. I hope you're having a great night. I'm starting a little bit earlier than I scheduled this, but hey, I figured we should just go for it, right? No, I'm a little bit early. I hope no one is actually waiting the 15 minutes, but we're gonna go for it. It is Sunday, March 5th, 2023, and I have some big news for you all. Yes, this is in the Hey, oh wait. And then I heard my own audio. This is in the form of prizes for you all. We got people in the chat. Abariu, welcome. First time seeing me live. Nice, welcome. Gautam, big announcement. Ooh, boy, that's right. We got a big announcement. So to get on with the announcement, I'm going to test this out. So I have like a little desk camera here. And I have some stuff over here that maybe we could open real quickly. Gotta make sure I'm not showing any top secret information, but if you look here, I have a package that came in the mail recently. Oh, this is horrible. This is absolutely horrible, this setup. Yeah, so we got a package here that came in the mail. And do you guys think we should open it? Should we open this and see what's inside? Hey, Thomas. We got Thomas in chat. We got someone in Brazil, someone from India. Welcome. Evan said JK? JK about what? Are you ready? You guys want to see what's inside? Ugh. All right, here we go. You can tell how bad I am at opening boxes now. What is this? Let's take some guesses in chat. Do you guys have any guesses what this could be in this box? That's such a big announcement, such a huge, huge announcement. They really did a number on taping this. Hello from Raleigh. Welcome. Can we live on? Can we do a live on Git? We need to eventually. We can maybe set up a Git repo today. I think we could do it. Maybe do like a. People are saying yes to open it. All right, so here we go. Here is opening the box. What do you guys think it might be? Any guesses before I show you? Here's a peek. Oh, I can see it. I'm looking underneath. I'm looking up underneath. Is it broken? No, it's not broken. It is. All right, let's get rid of this stuff. It is a nice and beautiful GeoForce RTX 3080 Ti, baby. Does anyone have any idea what this means? This means, let's put it back up there. This means we are back again, folks, for another PogChamps. We're going to be launching another Kaggle community competition, and the winner gets the opportunity to potentially win this GPU. Pretty cool, right? That's a pretty cool prize to win. Like 3080, little bit like older, but still a great GPU to get in your machine. This is better than the GPU. This for sure is better than the GPU that I have in my own machine right now. This is everything you'd want to do data science stuff on your computer. So you're going to have the chance to win that. I got to make sure I don't lose that box back there, because I'm going to have to use that to ship it to whomever wins. So that's pretty cool, right? Great announcement. Now, this is in partnership somewhat with the NVIDIA GTC conference that's coming out soon. So I'm going to have a link for you. Actually, let me put that in chat now. Let me put that in chat and turn this off, that camera off. I've got to find my link. Where is this link? Where is my link? My collaboration link. Here is the link. What you need to do to get on the list of potentially winning that GPU, the very first thing you need to do is use this link to sign up for GTC. You'll have to attend it. It's a virtual conference, but you just need to attend one of the sessions in order to be eligible. So you have to use that link that I just put into the chat in order to win the GPU. So that's pretty cool, right? Big announcement. But there is more. There is more. There's another box here. Should I use this? Should I open this other box? Or should I leave that one here? I think we should open the other box. So let's turn on our desk cam, our second desk cam. All right. Okay. This one's kind of big. Ah! Feedback. This one. Legs crossed. Here we go. This one's a little bit bigger. It doesn't even fit in the frame. Compared to that box, this one is pretty big. Now I need to think about how to open this. Oh crap, am I not going to be able to repackage this? Is this not going to be reusable? Well, got to bite the bullet. All right, let's start tearing this apart. Tearing this thing open in order to see what's inside. Data Dude has a guess. Data Dude has a guess as to what it might be. Oh, wait. Oh, man, this is like a... I need instructions on how to open this. Oh, okay. Maybe I should open it this way. Ah! I should have rehearsed this. Do you see that? I kind of don't want to... Oh, it's just too beautiful of a box. Look at this. Do you see what that is? Let's take it out. And put the box aside. Oh my goodness. This thing is huge. All right, headphones back in. Let's bring this thing up. It's a 40-something. Yes, it is not a 4090, but it is a 4080 RTX. This thing is humongous. Look at it. Look at that beautiful design on the top, too. So, yes, we are not only giving away one. We're actually going to give away 2 brand new GPUs to you all for being part of the community. And here's the deal. We are going to give them away. One to the winner of the Kaggle competition that we are going to launch. And one is just going to be to a random Kaggle competitor, not necessarily the winner. So you don't have to be exceptional at data science to win these. Let's put this up. Let's put these up on the shelf. But before I do that, let's just put them in one shot. Here we go. There you go. Who wants that? There we go. On the shelf it goes. Gotta move some knickknacks around. Oh my goodness. There's like no room for knickknacks on my shelf with all these GPUs. Okay, so just to recap here, we have a RTX 4080, one of the brand new 4000 series GPUs, and we have a 3080 Ti. Both of those are going to be given away as part of a Kaggle competition, and you don't necessarily need to win the competition to win a GPU. If you win the competition, you will win a GPU. I haven't decided which one yet will go to the winner and which one will just go to a random someone who's participating. When will you be launching the community competition? Great question, Bright Lyrics. I need to figure that out, but very soon. Let's look and see when. That's on my to-do list maybe later this week. But let's look and see when GTC is March 20th to the 23rd. So we have a little bit of time. Let's check out the calendar. Can you tell how much planning I've done for this? So we got 2 weeks before GTC launches. I would like the competition to launch, let's say, next Monday, which would be the 13th. That's my goal, is to launch it the 13th, have it maybe run for 2, maybe 3 weeks, depending on the data, and then the winner can win one of those GPUs. The only thing I'll say about the GPU is you need to pay for shipping, but aside from that, you get the GPU for free, so it's going to pay for itself, right? You could just turn around and sell it. The winner should have a RTX. Okay, we already got people saying what they'd like. Okay, should we do some coding? Should we do some coding? Enough of these GPUs. Make sure you use that link that I put in chat to sign up. And yeah, you'll be well on your way to getting that GPU. So you need to use that link. You need to subscribe on YouTube. You need to follow on Twitch, all that good stuff. And when the competition launches, I will let you know. Sound good? No, I don't want that. All right, so let's go back a little bit in time and remind ourselves what competition we were looking at in the Kaggleverse recently. There's so many good competitions being launched that I would love to work on, but you know, we don't have all the time in the world, so I got to pick one to work on, and we were working on the sign language competition. And I was looking at some of it today, and I think we can just pick up where we left off. Does that sound good? Someone's having Bright Lyrics having a machine learning internship interview today. Well, if you tell them that you want a brand new GPU, that would be great. Rob, why am I not improving at coding? Josh, you probably are. It just takes some time to look back and to have the perspective when you improve. That's at least my experience. Like you don't see the gains day by day. You see them when you look back months and years back. Quick shout out before we go look at this competition is and it's no longer here. Recently launched. I was part of helping run this competition for the NFL, which just completed this weekend or last week. Sorry. I was away at the NFL Combine this past week when the winners were announced. So I just want to congratulate all the top teams for doing some great work on this competition. So the goal of it was we provided a bunch of video data, and I had spent a lot of time making sure that we had good marked data for when contact occurred between players, because the whole goal is that we figure out when that occurs and situations that maybe are more dangerous, so we can figure out how to make the game potentially safer. And the goal was to predict when these moments of contact happen, either between two players or a player in the ground. And the leaderboard was finalized. We had some really strong competitors here at the top. NVNN has won handful of Kaggle competitions outright. We got Team Hydrogen, which is like a powerhouse of some of the best people on Kaggle. Demetrio has won the NFL Challenge 2 years ago. Osaka Tigers, which is like a powerhouse of all the really good competitors from Japan, who also, many of them have won in the past these competitions. And then it just keeps on going down the list, like all these really strong teams. And if I would encourage you, if you want to see some great discussion around how they approach this problem, then check out the discussion forum, which I just put into the chat. So read some of those solutions that were written up by these top teams, because they did some great work and they deserve to get the credit. Now on to our competition. So this competition that we were working on last time, the goal of it is to use the output of MediaPipe, which is a open source. Well, I don't know if it's open source, but a freely available pose and hand and face detection software by Google. Software solution, I'm not sure what we call it. So we are given a bunch of data from that, and we are trying to predict what American Sign Language. I don't know why I'm pretending like I know American Sign Language. I don't. But I need to learn a few things. Just if we're going to work on this competition, a few signs. But the goal is to be able to predict out of, I believe, 250 different signs, which are from which the person is signing from the MediaPipe output. So if we remember before, we made this notebook, which I'm going to also put in chat. You can go on here and upvote it if you'd like. We made this just exploring the data a little bit. We didn't actually get to the point where we created a model, but we did kind of understand what the different signs were that we were trying to predict. So these were the top 50 out of those 250. Hey, SQL Slaughter, welcome to the family on Twitch. Thanks for hanging out. We got to spin the wheel for SQL Slaughter. Thank you. New follower, I've been watching my videos. Nice. I spin this wheel every time we get a new follower. Can I put the dark mode on this? Yeah, let's see how that looks. I spin this wheel and it lands on dad joke. Let's give you a dad joke. Funny dad joke. So here's a dad joke for you. I got to pick a good one. I used to be able to play the piano by ear, but now I have to use my hands. Oh, that's a really bad dad joke. I apologize for that one. We should just take that off the list. So we were looking at some of this data and understanding the targets that we were trying to predict. And then we were trying to understand what data points we had that we were trying to use to predict. Most of the points come from the face detection, and that's because MediaPipe, when it predicts your face, it has all these different points that it's predicting. When it predicts the hands, it's looking at just the main key points of your hands. So we can look at the hand detection here. It's an example of the hand detection, right? And then they also did, I think, the base pose. They have the pose detection, so we can go here and see what the pose looks like. So it looks at just some main points, key points in the body that it can use for identifying, like the elbows, the relative to the shoulders that people are using when they're giving their sign. We also looked at the rate of keyframe points within the data. So left hand and right hand are split up separately. And then what did we do here? Oh yeah, so this was like the 3D representation of the pose with the face, and it's a little hard to see because this is 3D. But the hands are in front of the face, and this might be a little bit easier to see, is actually the person's face. And then these were the hands of the shush. So you could see like the fingers are curled and they're pointing up and kind of doing shush. And that should be good data points to train a model on. What else did we do? We try to run this on just some images that we had. And yeah, we're going to take it from here. So someone asked if we could do a Git tutorial. And maybe this would be a good time to kind of dive into that as we create a Git repository for this competition that we'll start working with. My dad jokes equals the best jokes. Thanks. One of your Kaggle projects was to use the example in the March 2021 book, Data Governance, the Definitive Guide by O'Reilly Media. One of my projects was, David? I'm not sure what you're referring to. So what we're going to do is we're going to go to GitHub, and I'm going to create a new repository. I'm going to call this sign language. No, we want to go to actual competition. ASL Signs is the name of the competition. So I'm going to name the repository Kaggle-ASL Signs. And then I'm going to put competition code for the ASL Signs competition. That is repetitive. So I'm going to say code for the ASL Signs competition on Kaggle. We'll make this private because I don't know if I'm eventually going to make it public or not. We'll default this to having a README, and then we're going to add a git ignore file by default. Git ignore just tells Git which files to ignore. So inside of it, if we pick Python as our default template, it will decide which files to ignore based on that. And you'll see this once we load it up. So we're going to create this repository, and there we go. We have our ASL Signs GitHub repository. I am the only one watching it right now. And now we have the SSH link to this repository. So I'm going to go into my repository folder on my desktop, and I am going to use git clone to clone this repository. That's going to pull it down local, so I have a Kaggle ASL Signs folder now, which is actually linked to GitHub. Does this make sense? Am I walking through this too basic for you guys? Yes, figure 1 to 6, an example analysis and visualization of NFL data in Kaggle notebook by Rob Mulla. Oh, wait, you're saying my project is in that book? Can you show me a link to that? Data governance, an official guide. I don't have this purchased, but send me a screenshot. That's cool to know that I'm in a book. Is it safe for you to do dual stream? Safe in what way? In what way? I feel safe. Do you guys feel safe? I feel safe. All right, so we're in our Git repo folder here. Now, let's look at this git ignore file to understand what it is. So it's basically listing out all the common types of files that Python projects have that you don't necessarily want to track with Git. So Git is our version control for the code base, but we don't want to track things like data. Data's big. We want to track things that only have code so that we can track when the lines of code change. And we don't want like big text files. We don't want these build. We don't want downloads, eggs, like compiled software. We want the raw source code. So that's what this will add by default. If you just use the GitHub default git ignore for Python, but we're going to also add some other stuff. So we're going to add data. So basically, if we put a star, it will account for any file that has like the previous name as anything. Star is basically just anything, and we're going to do a Parquet. We're going to do star.csv, star. Yeah, that's about it, right? Then we're going to in here make a folder, make a directory called input. Now in our input folder, so I want to kind of show you if I make a file in here, if I make a file in here called pull data.sh, and normally I would just write this in my terminal just directly, but I'm going to make it into a shell script so then I can sync that with GitHub, or I can actually make a commitment to GitHub. Yeah, so this is they moved things around here a little bit on Kaggle, but here is the command, the shell command that I can run to download the ASL science data. So I'm going to go ahead and save that. Now, if I look in here, I have this pull data.sh shell script. Now, if I go up one directory and I do git status, it's going to tell me a few things. It's going to tell me all the files that I've modified or new files. I've modified our git ignore because I added CSV and I added Parquet files to ignore. So I'm going to add this git ignore. That's going to add it to a potential commitment. And now if I do git status, let's do git status. We can see now git ignore is in green. That's because it's staged for a commitment. So I basically told it, add this file to what we're going to commit in this next change. Now I'm going to do git commit and then -m because you have to add a message to your commit. And I'm going to say update git ignore. Hey, thanks for the 5 subs. SQL Slaughter, that's really nice of you. You didn't need to do that, but I appreciate it. So I'm going to go ahead and push that. I don't know if I did that too fast, but I committed it with the commit message update git ignore, and then I did a git push and I pushed the change, but now I'm trying to push it and it's saying everything's up to date. So that local commit was saved on my local machine. Then when I said git push, it's actually pushing to master origin, or it's pushing to GitHub. So if I go here to my GitHub, now I can see I have 2 commits, the initial commit and then this update ignore. If I go to my update ignore, I can actually see a diff between the files that before and what I changed. So I added these 2 lines, right? Anyone doing F1 data crunching after today's race? Oh, was it a good race today? I don't know about that. I'm not a big F1 fan, but maybe I could be. MMD came to say hi and good night. Good night, MMD. Eduardo asked what we're doing today. We are working on this Kaggle competition for ASL Sign. And we're actually just doing like a basics in how to use Git. All right, so now I'm going to go back into this input folder. If I do a Git status in here, we could see it's saying there's an untracked file in here, which is this pull data. Let's actually run the pull data. So in order to execute this, I need to modify. So if we look at this pull data shell script, it does not have rights to execute on my computer. If it does, you would see an X next to it when I do ls. It only has read and write access. So I'm going to chmod this so I can pull now execute it. Now if I do lc, we can see like all the executing local user, I think admin, and anyone can execute this. And it also shows up green. No module named Kaggle. So let's do conda activate Kaggle 2023. Now I feel like I'm just jumping ahead. So let's run this pull data shell script. Let's pip install Kaggle because I don't think I installed it to this conda environment. And now let's pull data. Let's see if this works. How big is this? 37 gigs. So that's pulling. While that's pulling, I'm going to add that file to our git commit. Git add pull data. Now if I do git status, we can see it's committed. And we're going to say git commit -m pull data script. And we'll go ahead and push that. Go back to GitHub. We can see now we have a folder called input in this pull data shell script. Now, one thing you'll notice is this zip file is showing up as an untracked file. What's up with that? That's because we haven't added that to our gitignore. So if I now add .zip files also to my gitignore, and I do git status, it's no longer complaining about that zip file, but is saying I updated gitignore. And I'll push this. All right, so that's a very basic thing with Git. That's really all I do with Git. There are other complicated things you can do. Don't you need to add probably to be fair, I'd need that bin bash to make sure that runs in bash with that pull data script. But by default, I'm in bash, so I'm just executing it from bash. What's up with the big announce it? Imposter Engineer, you missed it. Back there, I have two NVIDIA cards. An RTX 4080 and an RTX 3080. They're like brother and sister. And you have the potential to win them. We're going to be launching a Kaggle competition next week. And the winner and just a random person on the leaderboard, not even the winner, will have a chance to win it. You wish. Well, all you got to do is just get on that leaderboard and you have a chance to win it. Now, I did mention this before, but I'm going to say it again. You need to register using that link right there. That helps me out a lot if you use that link. Oh man, I can't type the bang. Oh, I'll enter your notebook. Post on Discord. Yeah, I need to post that on Discord. That'll be on my to-do list after this. My Gmail is showing a bit. Uh-oh. Uh-oh. Don't want to show that. Don't want to show that. Okay. Good now? Okay. All right, so let's get back to this. So we're downloading this data, but it's kind of large. It might take a while to download. Yeah, it's going to take like over an hour to download. Let's do df-h and see how much space I even have on this drive. I only have 14 gigs. So let's go ahead and stop that process and look to see where I have more data available. I have it available in Romola My Disk, Maker ASL, Kaggle ASL, Signs. And I'm gonna copy from my repos. Probably should do a soft link to this, but let's just do copy from my repos, ASL, Kaggle ASL. We're going to copy that here, and then we're going to run this here. So it's on a drive. It's on a drive that I have enough space to handle it, actually. Yeah, I need a few more hard drives. All right, I'm going to remove this other one. But I also want to go in here and take a look at some of the notebooks that have been out there that people have been using. So there was one that I was looking at earlier that's currently top of the leaderboard, pretty close to the top of the leaderboard. And this uses, I want to run this offline. So let's go ahead and check out the data they're using, because I know there's something on the data tab. They moved the data tab. Where's the data? Where is the data? Where going the data? Oh, here it is. I think it's this. Nope. If I click on data, it doesn't get me there. Where's that side thing where I used to be able to see the data sources? It's kind of annoying. I swear there was like a new, maybe if I turn off this dark mode, it's going to make it easier to find. Input. Oh, maybe this is it. Private data source. All right, so this is the on the shoulders data. And let's actually copy this and edit and turn on our dark mode again. What kind of data am I going to have on the competition on top input? I don't know what I'm going to do yet, but I'll take some suggestions in the Discord. ! Discord if you're on Twitch. And you can join us there. We'll be discussing it. Bright light. Yeah, I need to turn on the dark mode. All right, so this is called like data. feature creation. And this is from someone else who's created it. Let's see what they did. Quick test. Let's do true. ASL Signs has train landmark files, which is a bunch of Parquet files. And then this train file is a train.csv. And then this prediction map is a JSON file with all the labels. So load relevant data subset reads the Parquet file with only X, Y, and Z columns. And it reshapes it in the number of frames, rows per frame, and the length of it. That's right, because I remember this. When we're looking at this data before, they have null values accounted for. Even if they don't have the media pipe values for a given frame, they're going to give you a null row for that. Then what is this? TensorFlow.gather X right-hand landmarks. What are the right-hand landmarks? We don't know that yet. And then this looks like it's just filling in null values. Pre-process configuring. Number of frames is 15. Segments is 13. Okay, let's go back to our EDA. Didn't we look at some EDA of the number of frames? Yes, it was in this output. Train with metadata. New data set. ASL train with metadata. We're going to create this. Go to that data set. Let's go ahead and make this public. And we're going to take this data. We're going to just, for our own understanding, we're going to add this as a data source. Accelerator, view session metrics. No, I want to add in. Oh yeah, that's where it's this little thing now. Now I want to add data, which is going to be my new ASL train metadata. This is something we created last time. And it's basically just some metadata about each sign that we're trying to predict for. There we go. We'll just call this meta. And let's look at this. Why did that disappear? And I think I pulled in the number of frames that we have. So the shape of this is 94,000. But let's look at this number distribution of frame number in training data. That's a long title, but it's going to help. Probably don't have matplotlib in there. Okay, so some of these videos are pretty long. Like they can be up to 300 frames. And they're choosing number of frames to be 15. Is that right? Let's sort values. Or let's look at frames is less than or equal to 15. And then let's take the average value of this. So this means 34% of the videos have less than or equal to 15 frames. Imposter Engineers teaching forecasting tomorrow. Very simplified lecture. I remember you said you use the forecast hotel rooms rate. Any method suggestions for that data? It's always good to impute similar data from the previous year and then have your model just try to modify that slightly. Unless you have any other reason to. So basically the feature of the same value from the prior year is usually helpful. Unless it was a COVID year, then everything's crazy. All right, so 34% of these are less than 15. Let's see how many are less than 30. So more than half of them have less than 30 frames. And then there's this long tail where we have really long ones. All right, what's this left-hand offset? Okay, so this is just identifying, I believe. Actually, while this is going, let's take this output. And let's see if I can copy this to my local directory too. So basically take this. Come on, why aren't you working? Take this down here and do. Let's see if I can download the output of this Kaggle kernel to here locally. Doesn't look like it's doing anything yet. See if that works in a little bit. But we're just trying to understand how this data preprocessing works. And I think the way they're doing it is by taking this ASL signs and making some assumptions or like understanding of how these landmark files actually look. Yeah, so let's just take a random one. And look at it. Okay, so let's query where the frame equals 103. So now we just have the first frame and it has 543 rows. That's the number of data points I believe we have for every frame. And see here, the right hand does not, it's not in this. So then those are filled with null. Pink hand waving. Hey, Jose. What's the topic today? We're looking at this Kaggle competition, but we also have some GPUs that we're going to give away. That was the big topic from earlier. So they're averaging over the entire face, which they are saying is, so if we look at the row ID values, and we go from 0 to 468, it looks like that's what they're doing here, is they're taking this as, this is basically face The first 468 are for face. If I do 469, yeah, then it starts getting into the left hand. So now I see what they're doing here. This is essentially parsing out from this data where the landmarks are for the body, the pose, left hand, and the right hand. And then they're actually pulling out just the lips. So the final shape that they're using is a size of 84. That's because they're using this is a kind of confusing line. Item for sublist in what in the world is this line of code doing? Lip landmarks. The length of lip landmarks. Length of left hand landmarks. And the length of the right hand landmarks. 40, 21, and 21, which would be 82. So what's going on? Why is it 84 times 3? Oh, because the number of frames is 15. This is really important to understand if I understand how this model works. Point landmarks. Why this plus 21 too? Oh, because that's the length of the left hand. Okay. They could have made that into another constant. Yeah, so let's go here and let's see from this landmarks data. Query frame equals 103 and then type value counts. Yeah, this should tell us the length of each. So the pose is a length of 33, face is 468, left hand and right hand are each 21 points. Number of channels RGB. So this shouldn't be color. So I don't think that they need 3 channels. Gabriel. So why is this input shape 15 times 252? We love magic numbers, yeah. I think I at least understand what that's trying to do. Flatten means and standard deviations. So what I think this is doing... And here's the thing, all this data preprocessing must be done in TensorFlow because pretty sure it needs to be done in TensorFlow because this competition requires you to submit a TensorFlow Lite file for prediction. What is SQL Slaughter saying? In the past 5 years, I've gone from being a data QA tester from being a sensitive data engineer. But I really want to get into data science and ML. Your videos on YouTube have helped me a lot, but I feel like I have so much to learn. We all do. I still feel like I have tons to learn. So you're not alone there. It's okay to be sensitive about data. See how much this is downloaded. So this didn't work. This didn't download. Maybe I just need a... Here on this data NumPy, how big is this file? 4 gigs? That's not that big. Let's go ahead and just download this. Take a few minutes. Yeah, because this is the data that they use for training. But I want to understand how it's created. So what are they have this feature generation code, which takes, when you call it, it takes the X input. Expand dimensions, I believe just... Expand dims. Returns a tensor with length 1 axis inserted at index axis. Returns a tensor with length 1. Oh, so that's just... Yeah, that's like unsqueeze in PyTorch. What's this? Range in segments? Segments is 3. All right, so basically it's taking that input data and it's making it into a shape of 5796. And then it's converting and saving this data off. It's a little bit messy to understand exactly what's going on, but I think we get the gist of it. Well, I don't really get the gist of all this, but it would take me a while just to stare at it to understand. I think it's just padding, filling with averages. And then I don't know why it's splitting into 3 segments. Honestly, that's a little bit mystifying. But then it creates this output data, which I'm downloading right now. And then let's look at this notebook that actually changes, or actually works to train. And let's see if we can train a model. So let's download this one. Download code. We're going to go here. And make a notebooks. And then we're going to copy from our downloads directory just this file here. And then I'm going to open up a new tab. And I'm going to activate Kaggle 23, and we're going to go old school, not using any of that fancy stuff. Not using VS Code, but we're going to just go straight into using Jupyter Lab here. Adding a time dimension, there's... All right, so this notebook is built on top of the great work from the community. So this was someone else's work that made it possible. So he based this this code on someone else's notebook here. All right, this is a little bit cleaner actually. So this is just all the raw feature data converted into NumPy. And he does multi-processing, so it's probably pretty fast. All right, so he's reading in the XYZ Parquet data. He's using this feature generation module. And basically just averaging, like taking the mean value and the standard deviation, concatenating those together, filling null data with zeros. This is like a fill NA right here, this line of code. And saving that off. This took 11 minutes for him to run. And then what is this used for? Oh, here's end-to-end training in PyTorch. How does he train in PyTorch and then create a... All right, so this is a pre-processing code, but he's just pulling from NumPy. Number of epochs and batch size. This is our pretty standard creating a data loader, creating a data set. And then he can convert it to TensorFlow pretty easily. That's pretty cool. Onyx, that export. What's this Onyx? A TensorFlow backend for Onyx. Towards the Onyx export. Oh, so does he converts it into Onyx and then uses Onyx to convert it into a TensorFlow model. Final inference model in TensorFlow. So this just loads the saved model. In outputs. Okay, so I think I'm understanding what this does. This is pretty cool because what this is like a, definitely upvote this one if I haven't already. What this is allowing us to do is train. Onyx is a package for model exporting. If you save the model format Onyx format, you can load it anywhere. It makes framework agnostic. All right, so that explains what he's doing. So he's doing everything like normal, what you would do in PyTorch. But then at the very end here, because everything needs to be converted into TensorFlow Lite, he's doing this exporting of the input of the features, the input. I don't know what this feature generation path. Oh, this is just the output path of the file. Got it. And then you can just run this inference on TensorFlow. This is really helpful. And then testing it on one of the yeah, he's just zipping the file. And that's it. So that's one way to do it. I need to better understand how this, how he's reading this sign and label mapping it. So this feature generation class takes in X. Let's see how feature generation is. Feature converter is used. It takes in torch tensor X, converts it to NumPy. So it's loading the file, and it's just providing everything from that file. Load relevant data and subset. That loads everything and reshapes it. Rows per frame, 543. Converting one row, I think, makes this output. Yeah, because he's taking it, slicing where the face is, where the left hand, the pose is, the right hand is, filling null values. And then the resulting data is just the average values and the standard deviation of these. Like this. I wonder if there's any rhyme and reason to when the hand data are not available, because that would make a lot more sense for filling this in. But this actually makes pretty good sense for how you would train it. How did this one perform on the leaderboard? See the versions. He doesn't say the leaderboard score. So a lot of things to consider here. I think that we could do it with PyTorch. It'd probably be a lot easier. And then we could not necessarily flatten it this much. Now, one paper that I was looking at earlier, let's see if I can pull this up. Well, this is a different one. This is one that's using a recurrent neural network. So communication for hearing is hard for as exceedingly challenging task, which is why dynamic sign language was developed. So RNN models such as GRU, LSTM, and bidirectional LSTM address the issue of frame dependency in sign language movement. I'm researching some other solutions, Robert, that they use to predict sign language. So look, this is essentially exactly what we have in our data set. Hand pose, face, key points in 3D. That's what he has here. That's the face and pose. Let's see what their model shape was. No frames, no key points extracted. GRU model structure. They use DSL-10 dataset is a dynamic sign language that was created by the authors of this paper to adapt the methodology, which does not require high quality recorded data. Did they just run MediaPipe on this? MediaPipe without using face key points. In this experience, MediaPipe extracted 258 key points for the hands and pose as shown in figure 9. Then inserted them into the RNN model. Notice the key points existing on the face are not face key points. Yeah, those are part of the pose. They belong to the pose estimation. Table 2 shows the train and test accuracy. 99% accuracy. So it almost tells us that we don't need all the face stuff. I don't know if I buy this though. That's 100%. 99.3 and then these are just 90. This is worse. 99.3, 99.6 and this is 99%. After conducting the two experiments, it's found that the accuracy is very close at both of them. Hence, we prefer techniques that depends on the problem situation. For example, if the model will be used for a country that depends on facial expression. So they're basically saying it doesn't need. Hey, Nicholas, what's up, man? Hey, we just announced earlier I'm giving away some GPUs. We have a 3080 Ti and a 4080 Ti. And we're going to be launching a Kaggle competition soon. You should definitely join it. So I'm just reading a paper right now on how some other people have tried to solve this problem. But the thing is, we're not given much detail from this. But they did use MediaPipe as their input, which is almost identical to the data we're provided here. I'm just trying to understand the input data shape. Because this architecture is fairly simple. It's just a bunch of LSTM layers, a couple dense layers to get to the output shape. But it looks like they're only predicting out of 10 potential signs. We have 250 signs. So maybe that's why they could get such a high accuracy. Nice, got a link. Okay, so we haven't actually launched it yet. I've just done the teaser where I've shown the GPUs. Today was a little bit of unboxing of the GPUs. I'm going to actually have to make the competition, and it should be live sometime next week. But the The competition we're actually working on right now is this one, which you should know a lot about because I know you've done this in some of your videos. But have you seen this? This is a competition launched by Kaggle about doing the sign language recognition. This isn't something I launched. This is the actual Kaggle competition, like an official one. And it's out. They launched this a few days ago. 10 days ago. So there's still 2 months to get into it. I'm just trying to read some of the existing solutions that people have posted, and we did a little EDA on stream last week. I did yeah, where is this? My computer's struggling right now. Yeah, I created this data set from my EDA notebook where I ran some of the MediaPipe stuff on my own picture just to show it as an example. So it's interesting that this one paper said basically all these face points are a little bit too much or not necessarily important for the prediction. And just using the eyes and the mouth location from the pose detection was good enough. Right? So I'm considering potentially doing that. I also saw another paper was saying, oh, no problem, Nicholas. You can always hijack the chat anytime you want. Hey, Dan Boos, how are you doing? So I'm, funny enough, but I'm doing a lot of just downloading data right now to get it ready to go. But I would like to go into this best model here and fork that one. Oh, not this one. We almost have the data downloaded. It's 3.9 gigs. 3.1 gigs is done. Let me make sure I'm not going to overload. Oh, I only have 9 gigs left on this machine or on this drive. All right, best score. Sign language, cool. Yeah, Robert. All right, perfect. I dropped the face mesh landmarks when I trained. I think it was 468. Still decent results. Have you, so Nicholas, when you did that, you did it for this competition or you did that for your video? What was your architecture like? Let's copy and edit this version. Oh, in your video. Nice. Yeah, you should have a leg up on everyone on this one. I would love to see what you come up with. PyTorch versus Onyx plus TensorFlow versus TensorFlow. For pose detection and hand gesture detection from many videos, PyTorch would probably be very slow. David, what do you mean? If you're converting and you're doing all the training in PyTorch, it's going to be pretty fast, but then you think the conversion into Onyx is going to be a slowdown? Once it's converted into TensorFlow, isn't it just going to work like it was native? Come on, draft session starting. Yeah, it would be nice if I had this data local. Let's see if it's done downloading here. Feature data, feature labels. I think it's done downloading. 4.4 gigs. Let me just make sure. All right, let's go into here. Input. Process data. And open that up. And then copy this from our downloads. Feature data here. That's going to be moving a few gigs of data. And then we're going to feature labels here. All right, so I think those are good to go. Now we should be able to run this locally and not have to worry about the other thing loading up. So pip installs starting. Uh-oh, I don't know if I like this. Why all these print versions? I guess that's nice to actually print out versions. I think I already have. Oh, so it's doing a try except and trying to import media pipe first. No module named TensorFlow. Oh, so when are you going to make videos on Plotly Dash? I need to do that, Camus. What's the announcement? The announcement was 2 GPUs are going to be up for grabs in a Kaggle competition that I'm launching soon. Okay, what did you say, Nicholas? I need to read this because this is the good stuff. I lie. I kept the face mesh landmarks. Okay. It was 3 stacked LSTM layers followed by 3 fully connected layers. It looks like these people maybe published a paper copying your work. Do you think that's true? It depends what the date is. This was released in 2022 after your video came out. Yeah, because that's all they're doing. 3 LSTM layers, 2 fully connected layers. I guess it's ReLU activations across the board. And then softmax at the end. Yeah. So they tested different parameters, but pretty similar. You got a jet. Okay. Take it easy. Thanks for stopping in, though. Appreciate it. If you guys don't already know Nicholas's channel, which I'm sure you guys do, definitely check it out on YouTube. He does really good, really cool stuff. Big announcement. Big announcement with the GPUs. So I'm a little bit all over the place here with what I'm trying to install. Pip. We're going to upgrade pip. Then we're going to go in here. Let's see what these people did. Import starting. No module named Kaggle datasets. Why did they need Kaggle datasets? I don't want this. No model named Levenstein. Pip install Python Levenstein. I don't think we need that either. Is this just a bunch of imports that we don't actually need? Image IO. All right, we got those imports. Read the JSON file. Load the data. All right, we don't have the ASL signs train CSV yet, but we can download that. We can always go to the data file folder and just download these small files pretty easily. And then go into our make a directory called ASL signs. And then copy from our downloads this train zip file. And what's this other one called? Sign to prediction JSON, unzip this train and remove that zip file. Now, if we try to run this, we should, let's see what the base data directory is called. Data directory just needs to be up one directory into the input. Yeah. Okay. So now we have the input data and we have the JSON file with the predictions. We're going to do some pre-processing. This we won't actually run because we're going to pull from NumPy files. All right, so we don't want to actually load this relevant data file. And let's try to get this input into the new location. So this is a pre-processed data, our feature data, and our pre-processed data feature labels. And make sure this loads, okay. Okay, so let's see if that works. Hey, having some issues iterating over a data frame. Who is this? Oh, shoot. I didn't scroll down in the chat. Take a shot at CNN. I would take a shot at a CNN LSTM hybrid. Should be better than just stacked LSTM. Yeah, or some sort of transformer-based thing or 3D-based thing. This repo is not actively maintained. Yeah. Rob, do you work fully remote or in person? Mostly remote, but not fully. Like 99%. Pickle Kappa. Hey, Rob, can you link the paper, please? Yes, this is the paper we were looking at. Let's find it. I think I just downloaded, where are we on these tabs? Where is this? Download full PDF. No, that's not it. Now I can't find the thing. Let's go to Let's try to find it here. My downloads folder. Is this it? No, this is a different one. Nope. Maybe this one? Yes. MediaPipe landmark with RNN for dynamic sign language recognition. I will pull this up for you. This link. And I will put it in the chat. And you know what I've realized? Is I got to do a lot. Nick's recent video is relevant and fun. How to code machine learning lip reading app. That's really cool. Yeah, he's always doing cutting edge stuff like that. That's really, really cool. Someone's having issues iterating over a data frame. I need to iterate over the next 10 rows to check for some conditions and compare with the current row. What's the best way to do this without going out of bounds? You could do some rolling features, or if it's just 10 rows, you can actually just shift your rows down using the shift method. And if you shift all 10 down, then you can make like a bunch more columns based on those shifts. Be cautious about MDPI journals. Yeah, it doesn't look like that impressive of a paper, but I was looking at one recently that this is the one that I actually want to find, which is on a 3D spatial attention. Maybe this is it. Although it is MDPI. Yeah, so in this one, they're using a different type of architecture, a 3D graph convolutional neural network, I think. And I know these 3D GCNs are used in like molecular modeling. So, I mean, I guess the distances would be like your edges in the graph, and the nodes would be the locations of each point, but I'm not sure if that would be better for sign language necessarily. Yeah, so it's definitely worth checking out. What do you get when you cross a pirate with a data scientist? Someone who specializes in R. Oh, that is a good one. That is a great dad joke. I need to write that one on the wall and keep that one. Okay, so here's the deal. I think I need to download more data, and I need to get ready for really tackling this competition, understanding how that pre-processing was done. And I think I could do that offline, and it'll be a little bit more fun to talk about it when I'm done. Is very good papers using CNN plus LSTM for classification of single-step forecasting. It's nice because convolutional layer captures spatial pattern. Very nice. Yeah, that makes sense. Or some sort of 3D CNN. There's a lot of models specific for video that might be helpful. Thanks. I'll look into ShiftMath. Yeah, definitely. All right. So let me just show these last two before I end tonight. Ugh. We've got this 3080. We've got this 4080. In order to have the potential of winning these, you can join our Discord. like that. Everyone should join this and come hang out and we'll talk more about it. I'll let you know when it launches. I also would need you guys all to sign up for GTC, which is a NVIDIA conference coming up next month. And you can do that using that link. It's very important that you use that link so that I get credit for it. And it's completely free, I believe. So yeah, if you want a chance at this, do those two things. Check out next week when our competition actually launches, and we'll get into more detail about that. So with that, I'm going to call it a night, and we will start up again later this week when I've had a little bit more chance to look at this other data. And maybe we'll even, change gears a little bit and start looking at some data for the Kaggle competition. So I'm all ears. If you have any suggestions, drop them in the Discord. I appreciate you guys hanging out with me tonight, and let's do it again soon. Okay. Be nice to each other, love each other, and I'll hopefully see you on Tuesday night.